Hi there, this video is an exam paper walkthrough of the AQA GCSE Mathematics Higher Tier Paper 3 from Summer 2023. This paper is worth 80 marks in total and this is the fourth video of 4. It will focus on questions 19 to 23 which account for 20 of these marks. AQA Paper 3s are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 19. Two integers have a difference of 6. The integers are multiplied together. 9 is then added. Prove algebraically that the result is always a square number. So we have two integers, so let's use n. And then we need to use another representation for an integer where they have a difference of 6. So let's use n plus 6. So that's an integer that's 6 more than n. So to start with, the integers are multiplied together. And then 9 is added. So I've set up an expression here that I can now expand and simplify. N multiplied by n is n squared. N multiplied by positive 6 is positive 6n, and I still have the plus 9 on the end. Now what I know about a square number is it's the answer that you get when you multiply a number by itself. So what I'm going to do here is factorise this quadratic equation to find the factors that have been multiplied to make this equation, and then if they're the same, it shows me that it's a square number. So when we're factorising a quadratic, I'm going to need two brackets, two numbers that multiply to give me 9, add to give me 6. So 1 times 9, 3 times 3. 1 plus 9 is 10, so that doesn't add to give me 6. 3 plus 3 is 6, so that does add to give me 6, and they're both positive. So I have two matching factors here, which I can write as n plus 3 in brackets all squared. So therefore I can say always a square number. Question 20a. Sunil thinks that E and D are linked by the equation E equals 36 divided by D. The graph shows the values of D and E for this range of values here from 2 to 6 with those two values being included. Look. Choose one point on the graph and state if Sunil's equation is correct for that point. So let's pick the point. Let's go for an exact point here. Let's go for this one. So E at this point equals 10. D at this point, if we read down this graph, equals 3.6. So if we substitute these values into this equation, hopefully we'll get the answers that match. So apparently E is equal to 36 divided by D, which is 3.6. 36 divided by 3.6 is 10, which matches what we'd expect for E. So yes, it's correct for that point. (20b) G is directly proportional to the square root of h. G to h is equal to 3 to 2 when h equals 16. Work out G to h when h equals 100. Okay, so G is directly proportional to the square root of h, which we can write as G equals k times the square root of h. K is that constant of proportionality. So G to h is 3 to 2 when h equals 16. So 16 divided by 2 is 8. So if I multiply by 8 on the other side, 3 times 8 is 24. So when h is 16, G is 24. So h equals 16, g equals 24. We're going to use these two values to find that constant of proportionality. So we're going to substitute 24 for g and then 16 for h. So 24 equals 4k because the square root of 16 is 4. So then if I divide by 4, k is equal to 6. So now I can rewrite this equation for direct proportion as g equals 6 times the square root of h. So it wants us to work out g to h when h is 100. So when h equals 100, g equals 6 times the square root of 100, which is 6 times 10, which is 60. So g to h, g is 60 when h is 100. Question 21. A solid shape is made from centimetre cubes. The front elevation and side elevation of the shape are shown. So here's the front elevation, here's the side elevation, and we're dealing with a solid shape, so we're dealing with a 3D shape here. Work out the maximum possible number of cubes in the shape and the minimum possible number of cubes in the shape. So we're dealing with a 3D shape here. So if I just try to do a little sketch. So if this is the front part of the shape, and then this is the side elevation of the shape, so that was 5, 8 and 7, then the shape is going to look a little something like this. Really, really rough drawing. So for the maximum possible number of cubes in the shape, if the cubes were their minimum value of 1 centimetre per side, so if they were 1 centimetre length cubes, so they were 1 centimetre squared, then it would simply be a case of working out the volume, and that would be how many of those would fit in. So the volume of this shape. So I'm going to start by working out the area of this. So 5 times 9. And then this length is 8, this is 5, so this must be 3. 3 times 7 is 21. So 45 plus 21 is 66. So that's the area of this part here. And then I'm going to multiply it by 12. So 66 multiplied by 12. So the volume is 792 centimetres cubed. So there's 792 cubes inside that shape maximum. The next thing is the minimum possible number of cubes. So this one is slightly trickier. And the way that we're going to find the minimum number possible of cubes inside this shape is to assume that the shape is hollow. So what I did here, I'm now going to split this shape a little bit further into 1 centimetre sections there. So this is now no longer 5, this is 4. And that would be a 1 centimetre. And then this is 3, we worked that out up here. And then 3. And we've got that length there, 7. Okay, lovely. So I'm just going to work out how many cubes, 1 centimetre cubes, would be in these 3 sections. And then that's just taking into account cubes around the outside of the shape, leaving a hollow part in the middle. So we're going to do this first one. So this part here. So that is 9 times 12 times 1. And then we're going to deal with this section of the shape here, which, if you remember, that is now 4 because we've used 1 here. That is 1, and so it's 4 by 9 by 1. And then the last section is going to be this one, which would be 7 by 3 by 1. So 9 times 12 times 1, 4 times 9 times 1, 7 times 3 times 1, and then if we add those together, 108 plus 36 plus 21 gives us 165. So there are 165 cubes minimum in that shape. Question 22. Shape A and shape B are shown on the grid. So we've got shape A and shape B. Describe the single transformation that maps A to B. So first thing we need to notice is if we're mapping from shape A to B, it's changed size. So if it's changed size, it's definitely an enlargement. Hasn't rotated, it hasn't flipped, it's changed size. So it's got to be an enlargement. Now what we need to recognise though, even though it's an enlargement, it's got smaller. And it's also changed its position, so it's going to be a negative enlargement. It's going to be a negative scale factor. So first things first, so 4 from here to here, 4 from here to here, and then 6. And then the corresponding sides here, we've got 2, 2, and then 3. So everything's been halved. So it's a negative scale factor of a half. So it's a negative half. We now need to find the centre of enlargement. So hopefully by matching up the corresponding sides, they should cross at a point that identifies the centre of enlargement. So you can see here, it's at 7, 4. Question 23. We have a diagram here. A boat sails 35 kilometres north from A to B. So A to B, 35 kilometres north. From B, the boat sails to C and then back to A. So B to C and then back to A, and it's formed a triangle. 23A. Show that the distance the boat sails from C to A is 79 kilometres to the nearest kilometre. You must show your working out. So we're finding this length here, AC. Now I've got a triangle, and what I'm going to do is I'm going to find this angle here, because with that north line we've got a straight line. If this angle is 80, this one must be 100, because angles on a straight line add to 180 degrees. Now I'm going to use the cosine rule. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos A. So A squared in this instance is going to be AC, the length that we're looking for. So AC squared equals AB squared plus BC squared, subtract 2 times AB times BC times cos of the angle of 100 degrees. So AC squared equals, let's substitute in what we know. So AB is 35, BC is 65, so 2 times 35 times 65 times cos 100. So AC squared equals 35 squared plus 65 squared minus, now I'm going to put this in brackets because I want all of this to be together, 2. So I'm writing it just as I've written it here, look. So AC squared is 6240.099208. So AC, that length, is going to be the square root of this value. Which is 78.9942985A, which I can round to 79 kilometres to the nearest kilometre. 23b, work out the bearing of A from C. So we need this diagram with us again here. So we want the bearing of A from C. So we're looking for this angle here. We're starting at C, working our way round to A. So we're going to have to use some angle facts here. The first angle fact we're going to have to use is that these two angles here, this angle and this angle, are co-interior angles because of those parallel lines, those parallel north lines. So they should add to 180 degrees. So 180 take away 80 tells us that this angle here is 100 degrees. Angles around a point sum to 360. So we're going to do 360 subtract 100, which is 260. And that is the bearing of A from C.